Abstract. Municipal water supply and drainage pipeline is a key component of underground pipeline, and the design of a monitoring system is of great significance for its development. In this paper, the machine vision network is established, and the integrated monitoring system is introduced to design a monitoring method for municipal water supply and drainage pipelines. The communication sensor network is introduced to ensure the comprehensive monitoring of information. At the same time, the information management platform is introduced to combine digital monitoring and radio monitoring, and alarm software is set to complete the accurate display of data. The method proposed in this paper can effectively combine big data content and urban management content, better extend the industrial value chain, and ensure the realization of urban intelligence. The experimental results show that the relative error of the online monitoring method of municipal water supply and drainage pipelines based on machine vision is always less than 0.02%. The monitoring process will not be affected by wind speed and can well ensure the operation safety of municipal water supply and drainage pipelines. Keywords: machine vision, municipal water supply and drainage, water supply and drainage pipeline, pipeline monitoring, online monitoring, monitoring methods. Introduction. The drainage pipeline is a continuous tunnel space with power, network, rainwater, heat supply, and other pipelines. At the same time, there are also vents, manholes, and feeding ports in the drainage pipeline. The drainage pipeline is equivalent to a network system under the municipal infrastructure. During the construction of a smart city, machine vision is introduced, combined with security management and command management. Sensor nodes are fed. The set sensor nodes are used to sense, monitor, and perceive the data. The wireless sensor network can assist the drainage pipeline in comprehensive monitoring. Design of comprehensive monitoring system for municipal water supply and drainage pipeline based on machine vision. During the construction of drainage pipelines, it is necessary to minimize the potential safety hazards in all aspects of the drainage pipelines and ensure that the top floor area and the bottom floor area are separated. The two areas are on two interfaces, so that the top floor area and the bottom floor area are managed separately. The bottom floor area has multiple functions, such as early warning, positioning, safety precautions, environmental monitoring, and etc. The designed municipal water supply and drainage pipeline integrated system has multiple pipelines, heating pipelines, power pipelines, drainage pipelines, and etc. The top-level area needs to have the function of gas management, power production management, water supply management, and heat supply management. The bottom-level area transmits the toxic gas concentration information, temperature information, humidity information, and other environmental parameters of the drainage pipeline to the top-level system through machine vision, so that the bottom-level system can establish a connection with the top-level system. Machine vision is basic technology for the establishment of the municipal water supply and drainage pipeline comprehensive monitoring system. It can ensure the stability of the bottom system and the top system of the drainage pipeline so that they can operate stably and reliably. According to Figure 1, the structure of the integrated monitoring system for municipal water supply and drainage pipelines mainly includes intrusion prevention system, geographic information system, visual inspection system, and etc. A new water environment monitoring and early warning solution based on machine vision technology is developed. It uses the 5G wireless sensor network to realize the integrated monitoring of municipal water supply and drainage pipelines by measuring the reflected light intensity of the water. Through the centralized management of the environmental monitoring subsystem, equipment monitoring subsystem, radio monitoring subsystem, intelligent access control system, and alarm system, the smart goal of drainage pipeline is achieved. The information management platform contains a large amount of pipeline corridor information, cloud computing, big data, and data aggregation. Technologies are used to classify and summarize the sensor information, environmental monitoring information, equipment operation, status information, fire alarm information, etc. Municipal water supply and drainage pipeline comprehensive information management platform, and from information management images on the monitoring terminal display screen, sensor terminals, and mobile intelligent equipment of the drainage pipeline, so as to realize the command, dispatching, control, and monitoring of drainage pipelines. The Municipal Water Supply and Drainage Pipeline Comprehensive Information Management Platform mainly includes the following requirements. First of all, the monitoring terminal can display all business information, provide databases for the normal operation and production scheduling of the drainage pipeline, and solve the potential security risks in the drainage pipeline. Under the machine vision technology, the water flow in front is tracked in real time based on the continuous images. The search time is improved through the real-time tracking method. The target data in the image sequence is tracked in real time to determine the moving track of the target. The correlation tracking method, difference image, and pattern recognition method are simultaneously applied to the machine vision technology. If the sampling interval of the image is short, it means that the moving distance of the detected target water state is small. Using a local window for detection can effectively improve the detection speed. To process a water flow state road tracking in front of municipal water supply and drainage pipeline road based on machine vision is shown in fig. In order to verify the effectiveness of monitoring method based on machine vision proposed in this paper, the municipal water supply and drainage pipeline monitoring method based on machine vision proposed in this paper is selected for its experimental comparison with the traditional municipal water supply and drainage pipeline monitoring method based on data knowledge and the municipal water supply and drainage pipeline monitoring method based on traveling wave technology. The experimental environment is implemented with help of virtual machine VMW Workstation 8.2, which simulates 5 master machines and uses dual-core processors and slave single-core processors. The programming software is the Eclipse SDK, and the network address are set to 192.168.121.5 and 192.168.122.5. Set the experimental parameters are shown in Table 1. Conclusion: the online monitoring method of municipal water supply and drainage pipelines plays a key role in the maintenance and operation of drainage pipelines. This paper designs 5 subsystems, including environmental monitoring subsystem, radio monitoring subsystem, intelligent access control system, and builds a comprehensive information management platform for municipal water supply and drainage pipelines. Through this system, the safe and stable operation of municipal water supply and drainage pipelines can be achieved. The following conclusions are obtained through research. First, The online monitoring method proposed in this paper can predict the fault location in 0.45 seconds, and the error of the actual fault location is less than 0.3 meters, and the early warning ability is good. Second, the online monitoring method proposed in this paper always has a small difference from the actual fault location. In 1.1 second to 1.6 second, the location of the fault is basically consistent with actual fault location, and the location ability is very strong. Third, with the increase of research time, the environmental protection rate of the project applied in this paper is also increasing. Fourth, the current frame image obtained by this technology and the approximation of the flow state are more obvious. The difference between the two adjacent frames can more clearly reflect the moment trajectory of the flow state. The extracted flow status features are more consistent with the actual information of the flow state.